today's video, you'll learn how to add HTTPS to your Kubernetes services. We'll walk you through each step, explaining the underlying concepts and answering common questions along the way. When working with something like a deployment or a stateful set that's exposed via a service, we typically use another networking resource to deliver things like routing and TLS encryption. Usually, we use the Ingress ecosystem for this. However, this can be a lot of work and additional Kubernetes resources, as we have to manage Ingress classes, Ingress controllers, and Ingresses themselves. Instead, we may just want to expose users directly to an HTTPS service for our Kubernetes application. So today, we'll be discussing a different approach, showing you how to set up an HTTPS service without the use of Ingresses. We'll provide video links for how to leverage Ingresses and the new Gateway API, should you choose to pivot to those instead. It's important to note that introducing certificates implies the need to manage ACME challenges and certificate renewal. To simplify this, we'll use the easiest open source option available today, the Cert Manager project. The Cert Manager project allows us to integrate certificates into our applications without having to modify the application code and can take care of a wide variety of certificate provisioning and renewal scenarios. Getting started in the console, we'll create a cluster. I'll be choosing an autopilot cluster here, as it makes the process more streamlined, requiring less management of things like node pools. Once the cluster is created, we can deploy our resources. For demonstration, I'll be using the Cloud Shell IDE, but you can use any IDE that you're comfortable with. First, we'll get this application running without HTTPS. We'll do this as plainly as possible with just a deployment and service object. Now, since we're running on Google Kubernetes Engine, if we deploy the service, we'll acquire a Google Cloud Load Balancer and a public IP that will route traffic to our application on port 80, but without the use of encrypted HTTPS. Let's change that and make our application secure by provisioning a certificate for HTTPS. We'll achieve this through a project called Cert Manager. To install Cert Manager, we're going to use Helm, a package manager for Kubernetes. We'll add the Helm repo and then run the install. With that, we'll be able to deploy our certificate issuer, which is based on the HTTP ACME challenge and certificate resource itself. Bear in mind, this setup is intended for standard Kubernetes installations. If you're using GKE Autopilot specifically, based on restrictions around the Kubernetes system namespace, we need to adjust an additional variable for the leader election namespace. But once that's in place, we can generate our certificate resources. Upon deployment of our CRDs, we should have a Cert Manager pod managing our ACME challenge and an Ingress to direct our domain to that pod for the challenge. Since it's not giving us an IP, let's shift over to the default GKE Ingress class by leaving that part of the specification blank. Now that we've secured an address, we can incorporate it into a DNS A record for our domain, nginx.notomatic.io. I'm going to use an alternate DNS provider and input the record on a different screen. You're free to use any DNS provider. All you need is to configure an A record to link this domain to this address. You can examine various resources around the certificate, but ultimately, we'll be waiting for the associated Kubernetes TLS secret to be ready. Once the certificate is good to go, we'll need to slightly tweak our workloads and establish relevant configurations. We'll incorporate a sidecar proxy container that utilizes the open source Traefik project and reformulate some TLS configurations based on the certificate secret that we generated. We'll operate on the 8888 TCP port and pass the traffic to the other container housed within this pod, which is our original Nginx container. Let's create the config maps for these configurations and apply all resources to ensure our application has all these latest enrichments. Also, update your earlier DNS-A record to now point to the load balancer service IP instead of the auto-generated ACME endpoint. Once everything stabilizes, we can transition from our IP and HTTP to a secure HTTPS connection for our web application. We hope you found this Ingress alternative useful. We'll keep an eye on the comment section for questions and want to thank you for watching. Please enjoy responsibly.